We are talking about some stuff that we'll need for proofs. And there's two big definitions that we need for today. It's postulate and theorem. Okay, a postulate. A postulate is, sometimes they're called axioms, but I don't know. I think the best way to define it, I didn't really look to see how this book defined it. Basic assumption. It's something you don't prove to be true. You just kind of start by assuming it's true because it's kind of basic. For example, you guys kind of did this the other day. Remember when we had that paper and we were like, the big angle is, screwed it up. Let's say the big angle is like 70 degrees and this little angle is 30 degrees. Then how do we find that angle right there?
You subtract.
Right. Because you kind of assume that this little angle plus this little angle equals the big angle, right?
Yeah.
That's called the angle addition postulate. Because you don't prove it, it's just kind of a duh statement. It's too basic to be proved to be true, so that's a postulate.
So postulates don't need to be proved.
Right. But you can use them to prove other things, and those things are called theorems. So a theorem is something that can be proved. I wonder how they define it.
So like the Pythagorean theorem?
Yes, Pythagorean theorem. There's like 7 different ways to prove the Pythagorean theorem. Theorems are statements that are shown to be true by a proof, which is a logical progression of reasoning. So anyway, they can't. They're like rules. Like you guys remember Pythagorean theorem from last year. We'll be seeing that again this year. But they can be proven, or you guys remember the quadratic formula? That can be proven to be true. But yeah, they can be proven. And we will be proving some kind of basic theorems. Not today, but in the future. And it kind of is, it's kind of a way of step-by-step reasoning through, okay, I know this is true, and I know this is true, therefore this must be true. So that's what a theorem is. Yeah, so Pythagorean theorem, and this is complicated enough that you wouldn't have known it, right? Like, you guys remember what it was, Pythagorean
A
theorem?
squared plus B squared equals C squared?
Yeah, that's not like an intuitive thing to know. But somebody figured it out using a theorem. A squared plus B squared. And, that'll be like 5 months, we'll go over that again. That's not today, though. So theorems can be proven using postulates, definitions, and previously proven theorems. So if we already have a theorem that we know is true, we can use it to prove a newer theorem. Does that make sense? So theorems can be proven using postulates, definitions, and previously proven theorems. So one of the definitions we have right now is like yesterday we did parallel lines. So I don't know, if you're trying to prove that these something and you said the point A and point B are not on the same line because parallel lines don't intersect. That's the definition of parallel lines. Okay, so that's an example. All right, I'm on page 12. Go ahead and flip there if you haven't yet. We kind of need to read through these. These are basically going to be our answers that we're going to be using today, these different things in the green box. Okay, some of these we kind of talked about yesterday, but I didn't name them. You do not have to have these memorized for like the test, but you do, they will be like you'll have to look back and write them down for answers today. You kind of do need to know some of these rules, though. Okay, expansion postulate. A line contains at least 2 points. A plane contains at least 3 non-collinear points. Space contains at least 4 non-coplanar points. So yesterday we talked about that any line can be named using 2 points on the line, right? Like point 8. So we could call this line AB. And there's not going to be another line with points A and B on it. Does that make sense? So any 2 points define one line. So they're saying a line has to have at least 2 points. Any 3, remember talking about this yesterday, any 3 non-collinear points, points not in a line, define one plane. Okay, so if there's a plane, they're saying there's going to be at least 3 points on there. Really, there can be infinite points. Points, remember I said points don't have any size, and planes are infinite also. But to define a plane, you need at least 3 non-collinear. And space, which is what we're living in, 3-dimensional space, you can define. This won't really apply to this class, but you could define it using 4 points. I don't know why they threw that one in there, really. Okay, line postulate. Any 2 points in space are in how many lines?
1.
Okay, that might be a question on the test. Like, any 2 points in space are contained by how many lines? 1. Okay, but it's also a postulate. They called it the line postulate. Okay, there's not another line that's going to go through those 2 points. That's not a line. All right. Plane postulate, almost the same thing. 3 non-collinear points lie in exactly one plane. Not 0 planes, not 2 planes, not 3 planes. There's only one plane that is covered, that covers 3 non-collinear points. Got it? Logged it away in your brain. Flat plane postulate. If 2 points lie in a plane, then the line containing those 2 points has to be in the plane also. That's kind of a duh statement, isn't it? If you understand what they're saying 2 points are in a plane. Well, what do we know about a line that contains those 2 points? It's also in a plane. Get it? Remember, I said postulates are things we assume to be true, not things we prove to be true, because it's kind of duh statements usually. Some theorems are pretty simple. Like you might think I knew that already, but they can still be proven to be true. Line intersection postulate. If 2 lines intersect, how many points do they intersect at?
1.
Only 1. They say exactly 1 is how they put it. So not 0, not 2, 3, 4. They can only cross once. Line intersection. We kind of talked about this yesterday before I even read it. When planes intersect, where do they intersect at?
A line.
One line, yeah. And they call that the plane intersection postulate. By the way, if you read a different textbook, they might call it something slightly different. There's nothing like, there's no like king of math that said it's going to be this. So everybody kind of does slightly different things. Well, anyways.
You're the king of math.
Yeah. Okay, so if you turn to the next page, 13, those green boxes have 3 theorems that they mention. So everything that we just talked about was a postulate. Okay, like any 2 points are contained by exactly one line. That kind of thing. Those are postulates. On this next page, it says theorem, a line, and they didn't name the theorem. Or they call it 1.3.1. There's definitely nothing special about that. A line and a point not on the line are contained in one and only one plane. Okay, let's talk about where they got that from. A line and a point not on that line are contained in exactly one plane. Well, how could we prove that's true? That might not be obvious that that's true, but it is. Well, using that first postulate, any line has at least how many points?
1, 2.
2. Okay, now I have 2 points and a third non-collinear point. So if we have 3 non-collinear points, that's contained by exactly one plane. They call that the plane postulate, I think. Yeah. So we've proven that any line and any point not on the line have to be in one plane. Okay, that's a theorem because you can prove it using those postulates on the other page. Now I'm down below. 2 intersecting lines are contained in, guess how many planes? We talked about this yesterday. 2 intersecting lines can be contained by how many planes? 1. They're exactly 1. Because, well, they have a point of intersection, but they each have to have at least one more point. So 3 non-collinear points are in exactly one plane. It's true. Okay? So these are little 3-line proofs. So the last one, 2 parallel lines are in one plane. Well, 2 parallel lines have to have at least 4 points, and they can't be collinear because the lines don't intersect. So 4 non-collinear points, it's got to be in one plane. Anyways, that's the end of that. So we're not doing number 2. Did you guys notice that? Yeah. Or sorry, not number 1, I mean. Number 2, you guys can answer that on your own, hopefully. Number 3, name 3 things that can be used to prove a theorem.
Points.
Somebody's taking notes. No, it's not points. Postulates, definitions.
And previously proven theorem.
Good job. Theorems are not just used in geometry. You could do algebra or calculus theorems or whatever. Even just like arguing whether, God exists. You could make logical arguments that are like theorems. Sometimes the problem with the logical arguments is sometimes people don't agree on the presuppositions, the postulates, I guess you could say. Anyways, number 4, you guys will figure that one out. Number 5, 2 blank are, so all these answers are going to be like on the previous page, if you're not sure. 2 blank are either parallel or they intersect in a line. I don't think I read this whole. Yeah, if you look at the bottom postulate on the previous page, it just says 2 planes intersect at a line, actually. If they intersect a line. Yeah, they could be parallel, they could intersect a line, that's 2 planes. Yes, you're right. Number 7, 4 non-coplanar points. You guys remember what non-coplanar means? Not on the same plane. 4 non-coplanar points determine what?
Oh, line.
No.
Line.
I have to look at postulates.
Planes.
No.
Points.
3 non-collinear points determine a plane. Space, yeah. That's kind of a weird one. We're not really going to be talking about space. We'll talk about things in 3 dimensions, but we won't really be talking about space.
That was space.
Yeah.
What was 5?
Planes.
Okay. Numero. Wait a minute, I forgot 9. Does line AB lie in plane? Okay, let me read the directions. Use the picture to answer the question. State the definition, postulate, or theorem that says you're right, basically. So on number 9, does line AB lie in plane M?
Yes.
Yes.
Oh, dude, this is doing
How do we know that? Get it done today. No reason.
Bro, this is like.
Okay,
The brain is not working right now.
number 9 is yes.
Why?
Which postulate said that's true? Yeah, flat plane said if 2 points are in the plane, then the line that has those 2 points has to be in the plane. So it's yes, flat plane. And you might just have to go back and read them again.
What page are they on?
14. Oh, the postulates are on page 12. I thought you were asking what page we're doing right now. What's going on? Okay, number 11. How many planes pass through points A, E, and D?
None.
E. Okay, A, E, and D, are those collinear points? Yeah. A, E, and D are 3 non-collinear points, which would be covered by how many planes? 1. So the answer is 1. Which postulate was that? I think they called that the
Plane postulate.
plane postulate, yeah. The expansion postulate is like the opposite. It says it backwards. If you have a plane, there's 3 points. This one's like there's 3 non-collinear covered by 1 plane. So yeah, it's kind of confusing. But yeah, that's just the plane postulate. 3 non-collinear points are covered by 1 plane, or in 1 plane. Defined by 1 plane. Number 13. How many planes pass through line CD and point E?
2. And then infinite. 1.
No. 1. Why is it 1?
3 non-collinear planes equals 1.
Okay.
Oh, I thought it was that.
But one of them is a line though, and then a point not on the line. You guys remember me reading that one?
There's still 3 dots.
Yeah, but they don't tell us that.
Would that be the expansion?
No. So the line and the point not on the line are covered by 1 plane. That was one of the theorems I read. Okay, they didn't name the theorem. So if they don't have a name, usually just write the theorem out. Let's see if they actually wrote it out. Yeah. I mean, it's like 1.3.1. I don't really want to write that. So a line and a point not on the line. This is the first theorem we talked about. How does it say it? Are contained by exactly 1 plane, something like that? Are contained in, okay, they say 1 and only 1, which is the same thing as exactly on the line. Are contained by exactly 1 plane. Alright. I don't know. Let's see. No, that seems too fast. We've barely been in here.
I think it's 11.
No, I think it is 55 because then we go to chapel, which starts at.
Yeah, that was 55. Wow, how did that go so fast? I talked too much.
Good job, Mr. J. Let's go.
Yes.
15.
Talking about.
What is the intersection of lines ED and DB? Where are lines ED and DB gonna intersect at?
D.
D.
So it'd be like the line intersection possibly?
Hold on, there's another question. Is there more than one point of intersection?
No.
No. So which postulate says two lines intersect at one point?
Line intersection.
Line intersection postulate.
Bro, what even is 17?
We should stop right here.
What even is 17, bro? Like,
What even is it? It just says draw as many lines as possible. It's kind of easy actually. Between the points.
So we're not gonna.
Do we need to do that?
No. Stop at 15. Go to 15.
Alright, that's fine. 16, not 15.
Like the whole assignment.
Yeah. Since it's Wednesday and
What if you do tomorrow or Friday?
this is why you are.
you can turn it in tomorrow or Friday.
So we're doing 2 through 16.
Yeah, you can stop at 16. So basically all the answers are somewhere in those green boxes.
3